Okay. So for all different types of communication technologies, it's not only wireless. There has to be prior standards. So a new manufacturer, say either on the transmitting side or on the receiving side, when a new manufacturer comes into the market, he follows, has access to the standards, and accordingly he develops his product. Okay, so that the new just if I think of the cellular implementations, so say there are different network vendors like Nokia, Siemens, or Ericsson, okay, Huawei. Now, when Huawei came into the market, uh, it knew what the standards are. Accordingly, they developed their network and they transmit everything. The signals are accordingly following the standards. So all the phones can now uh, receive and they can work with the signals from Huawei. Okay, who doesn't and now if I think of the receiving side, if there is a new phone vendor, okay, that vendor again follow the standards, so it knows how to what to do with the signal that is coming to that it is receiving. So since there are prior standards set up, both sides can follow, both sides know how things would work. Now, this, like we spoke of Ethernet last time. Okay, so that's for wired technologies. Now, who would develop the standards? The most important standardization body, or for overall monitoring, or the overall authority is International Telecommunication Union, ITU, headquartered in Sweden. Uh, so that is like for all types of telecommunications. Most of the time, it is the highest authority, and it also takes care of standardization. Now, the present technologies for cellular operation have two different streams. They develop two bodies for standardization. One is called 3GPP, the other 3GPP2. Um, and there was also some standardization from IEEE. It has been there. They are first very popular standards in wireless area is Wi-Fi. Of course, Ethernet is the first uh, popular, very popular technology for communication. Okay, all these are from IEEE. IEEE, all the standards come with some numbers from anybody. Like Ethernet has the number IEEE 822.3, okay. Token ring 82.5, Wi-Fi 82.11, and that has different WiMAXs, WiMAX 1, 2, 3, 4, 5, now up to 6. And so 11, A, B, G, N, okay, AC, mean different versions. But after the tremendous success with Wi-Fi, they thought that they might also develop technologies for cellular operation. And so they developed WiMAX initially for fixed locations. Later, it also went for the development with mobility, I mean the mobile users. Okay. So then the number started with 82.16e. Okay. There is also 16m now, which is the called second version of WiMAX 2, 16m. But that's not an important specification any longer because the whole WiMAX technology is dying out. Okay. Why is it dying out? Because in the competitive market, something else is winning. Okay. Who is that? We can see that there are three streams, including this WiMAX. Let us look at the 3GPP and 3GPP2. Well, now you guys know that we had uh, another operator in our country before, cellular, what is that name? CityCell. Do you remember?
Yes, yes.
CityCell. Okay. So they they that was the only operator in 3GPP2 with 3GPP2 technologies. For all others, it is 3GPP. Okay, so these are the technologies evolved over time under 3GPP. Okay, 3GPP, the standardization body, developed. It's a body. 3GPP is a body. It is comprised of many standardization authority, ETSI, and when I uh, authored my book, I in, included many figures and tables from 3GPP specifications. So I had to take permission from there, and it was a long process. A lot of things they checked, and finally they permitted me to use those things from the specification books. Now, so the specifications uh, I mean, evolved over time because of the advancement of the technologies everywhere. So this is the evolution under 3GPP. And let me quickly look at the evolution under 3GPP2. Okay, CityCell was using some of these technologies. Okay, we'll look at it more closely. Let us look at them one by one. First, 3GPP. So now, but let me tell you who is winning the market. Well, when I was, I mean, the early impression, WiMAX was developed long after the developments of this, long after the journey of this 3GPP and 3GPP2. But in the course of 3GPP and 3GPP2, 3GPP2 was thought to be the one who would win eventually. Okay, both were, uh, and the development of all these technologies have contributions from many different companies and academia. Okay, the research and development sectors, R&D sectors of many different large companies, and also the research sectors of the academia have contributed in the last 3 decades, or actually more than 3 decades, in the cellular communication area. However, the largest contribution has always been from Qualcomm. Qualcomm is uh, is also the largest chipset vendor of the phones, okay, headquartered in San Diego. So I did an internship there, and uh, that gave me the boom, okay, in this area. So since they are actually they if you ask who has developed the technology, okay, they have many companies have contribution. But if you want to get a single name, it is Qualcomm. Okay, their contributions are head and shoulders above the rest. Anyway, so what I found that, I mean, in San Diego, they had 36 buildings in the headquarter, and many of the buildings are very large. Okay, but anyway, these buildings were basically split into two parts. Okay, some buildings they develop 3GPP, and some buildings they work with 3GPP2. Okay, and when a Qualcomm employee say meet somebody else for the first time, the first question is usually which area you are from. Okay, which side do you work, 3GPP or 3GPP2? Okay, I was on the 3GPP side. Now, and I say that is the largest chip vendors. So if you have a good phone, and if you break it, then you'll find that the main chip is from Qualcomm. Okay, they have the, I mean, there are other chip vendors, but their chips have always been the best in the market. The most expensive one too. So only the good phones can afford Qualcomm chips. Okay, now the first technology I haven't shown here, 1G, first generation. It was AMPS. AMPS was an analog technology, like the radio, AM radio, FM radio. They use analog modulation, and you don't use ones and zeros for radio broadcast. Okay, so it's not digital. So AMPS was like that. By digital communication, you mean that the information is first converted into ones and zeros. Okay, at the information level, you have a conversion into digital format, ones and zeros. Then you do the further process. So 2G or GSM was the first on this side to come up with digital, and when that 2G could support only voice. And by voice and data, I mean that voice and SMS, these two services are meant here by voice. And data means all other types of uses like web browsing, emails, video. If you are using right now mobile data, okay, then you are using data for this class. So GPRS was the first technology to support data, and it was called, the generation number was given 2.5G. Then H came in. There is a column here to show you the theoretical maximum data rate. Okay, the practical data rate is actually lower, much lower. So H, and these early technologies used FDMA and TDMA to support multiple users together simultaneously in the cell. You know that there will be any, I mean, of course, all of you know that there are different base stations, and each base station has one or more cells around itself. So that's why it is cellular technologies. Now, in one cell, there are many people who are supported together. So how do you allow access of multiple users? So that technology, this multiple access technology, was a combination of frequency division and time division for these early technologies. We'll later uh, touch upon these things. Okay, that I mean, to support, first you chop the total available bandwidth into pieces, and different people will be allocated different parts of these different pieces. Okay, and a particular piece or frequency chunk will again be shared by multiple people, uh, one after another. Okay, so that is time domain multiplexing. So both are done together in these technologies. Then 3G came in, which is called UMTS. In the physical layer, the technology has the term WCDMA. So people actually use these terms, I mean, both of these terms interchangeably. And the same technology supports voice and data together. I mean, this column is showing what you find on the display of your phone. Okay, at the corner, there is a display, so you see 3G when you're using this one. Now, to support higher data rate, HSDPA was introduced, and then thereafter HSUPA. I was there in USA then. Okay, where I mean, my days were like this. Uh, uh, this HSDP and HS 3.5G days of of the development. Okay. Thereafter, for further spin, I mean, HSDPS could support data only in the downlink. Okay, downlink means, well, from the base station, you are receiving data on your phone, and uplink transfer means you are sending data and the base station is receiving. Okay, so like we do for download and upload. And you see that I mean, this is the first I mean, you can say boost in the data rate. Okay, a jump you have here with this 3.5G. And then it kept further improving the data rate because the data rate demand has been increasing in the course of time. Now, 3.75G represented the HSPA evolution. Okay, I mean, this this represents data flow in both downlink and uplink. It's also called HSPA plus, and supported even higher data rates. And all these technologies for multiple access used CDMA, which is a very smart solution. Well, guys, can you hear me? I mean, you're
Yes, sir.
just
Clearly,
just
sir.
to test. Okay,
Yes. Okay,
just to
sir.
check whether or not you are awake. Okay, I know I'm a boring teacher, and many of you may actually be sleeping. Okay, in this online class, I can't see. So maybe you have said somebody in the class, there is a negotiation that these few people will remain awake, and when the teacher asks something, they would respond. Okay, letting others sleep. Okay.
Yeah,
Oh, so that means you are one of those people who are supposed to remain awake.
yes, sir.
Okay. Okay, and now then I had to come back home. My father passed away, and I had to come back. My mom wanted me to stay here in Bangladesh. So I thought what I might do. Actually, I could learn there. I mean, it was the blessing of Allah that I had a chance to get insight into the technologies. So both 2G and 3G, I learned very well. And I just thought what I might do here. So I started learning LTE by myself uh, uh, because the specifications are accessible, but uh, only the experts can read. Okay, I mean, they are like law books. So ordinary people cannot learn from the original specification books. So when I came back, LTE specifications just first started releasing. Um, so I started learning from the original books, okay, mostly from the original specifications, with little help from other sources. And actually, I also had some. I could manage some trainings from uh, Qualcomm, mostly uh, using help from my friends back there in USA. So that was, yeah, I mean, that was definitely very helpful for me. I still,
Sir, how many months you were in Qualcomm?
well, these things let us not discuss here for some reasons. Okay, we're not discussing. But the key point is that the reason I'm sharing these facts is that so you feel that I have experience with the U.S. industries. Okay, and so there are things you which I can share, but people from the academia cannot. Okay, and so you trust what I share in the class. Okay, so probably it will help you. Uh, Trust me. Okay.
There are no issues trusting you, sir. We are definitely trusting you.
Okay. Okay. Um, no. So I had to work very hard because I had I mean I had to author the book alone. Okay. I mean here in Bangladesh I can't find a co-author, and it wasn't also easy for me to find a co-author back there in USA. Okay. Anyway, eventually when I published, since I was, it took me a while, okay, actually a few years for me to complete the whole book, because I mean, it was all, I mean, I had to delve into everything, okay, and learn everything by myself. So anyway, so when I eventually published my book, it was almost the days of LT Advanced. And Uh, s- so the first year, the book had good sales, but um, actually, I mean, a few other books also started coming out in LTE advanced area, and so most of the readers uh, got inclined into the this always happens that they got inclined into the books coming with later versions. I also started writing books covering LTE advanced, which is the real 4G. Okay, the LTE, the first LTE is called 3.9G, and the WiMAX that runs here also is actually 3.9G. That now it is not running. Okay, we had here before. So it was basically it was on 4G. 4G has some particular for all these levels like 3G or 4G. 3GPP sets some uh, requirements that you have to fulfill this requirement of data rate. Then you can call it 3G. Okay, so that wasn't fulfilled in the first LTE, but LTE Advanced definitely surpassed that requirement. So it is the real 4G, and I also and there's also LTE Advanced Pro, okay, which is called 4.5G. I have another table to show that part, uh, but uh, the tragedy is that when I was writing book covering 4. I mean LTE Advanced. Then I mean suddenly my sister was diagnosed with cancer, and the day she was diagnosed, I stopped writing, and uh, after 3 years, she passed away. So I tried to be with her most of the time. She needed a lot of support, and since then I never happened to go back to writing. Okay. Uh, so anyway, I dreamt releasing later versions of the book, if you read the preface of my book, then you would find that, uh, I mean, I express that intention also is in the preface of my book, but that just didn't happen. Anyway, so now 4G plus you can find on the display if you are using something called carrier aggregation or CA, which can include multiple uh, bandwidth. I mean, there is some different, uh, there is some maximum limit of bandwidth. Okay, that is 20 megahertz. But if somebody needs very high data, then multiple this type of chunks of bandwidth, multiple complete chunks can be combined. It is a feature called carrier aggregation. But we don't have that feature implemented in our country. Also, the bandwidth available uh, does not allow this type of aggregation. So in our country, 4G plus you can't see on the display. Okay. Also, all phones don't display 4G plus. But even if even the phone supports, it is not there in our country in the network from the network side. Well, the most recent technology is 5G. It already started rolling out last year, and that can also come with a display 5G plus. But if you are using very high frequencies, okay, the 5G first supports very high ranges of frequencies. Okay, all the technologies up to 4G plus uses frequencies below 6 gigahertz. 6 gigahertz. Okay, we'll spend more time on that later. But 5G can support frequencies up to 100 gigahertz. Okay, but in the initial specifications, their support in the 6 gigahertz, in the frequency below 6 gigahertz, and also another range in above around 30 gigahertz. Okay, so if you are using frequencies around 30 gigahertz something, then if it is not the low range, like the frequency range of other technologies up to 4G, the conventional technologies. Okay, if you're really switching to the new high range of frequencies allowed in 5G days, then it is on the display, you can find 5G plus, but the phone also has to support this 5G plus display. Okay, but only when, because on 5G, you may be either on the network can put you on the low frequency range or on the high frequency range, depending on your bandwidth requirement. Okay, so in the network, it depends on where the network has put you on. Now, you can see that there is also, I mean, the terms here for 5G, it is called 5G. Okay, but the wireless side has a term called new radio, NR. Okay, and a lot of times for 5G people is that term, NR. But the whole system is called 5G system or 5GS, because you also have the wired section, okay, core network. So anyway, so the radio side has the most changes always in the evolution of technologies. The wireless side, okay, has the most of the newer things. Okay, the wired side undergoes very little change in the course of the evolution. Okay, but you know that things are not stopping here with 5G. In future, there'll be 6G, 7G. We know how far we can go in our life. Okay. Now, these technologies are using OFDMA. Although 5G supports different versions of OFDMA, but LTE and LTE Advanced, they use OFDMA. However, in uplink, it is little different from OFDMA. In downlink, it is straight OFDMA. But in uplink, it is WiMAX uses OFDMA in both downlink and uplink. WiMAX 1, okay? But in uplink, it is called SFDMA, okay? a variant of WebDMA. 5G supports two variants of WebDMA. Now, in the course cellular communication in 6th semester, I mean, in this type of course, this is a new course here now, but even in the old syllabus, there are some course I used to offer. So I used to offer, say, when we had only 2G in our country, I used to uh, teach only 2G. Okay, I mean here at IIT. Then when the government introduced 3G, I started covering 3G too. Okay, a little bit 2G and mostly 2G and mostly 3G. Then when I mean the government introduced 4G, the license of 4G is issued, I started covering 4G. Okay, so I started updating considering the requirement, okay, or status in our country. Also, actually, a little bit from 4G I covered also before because it was there in other countries. And last year, I started covering 5G in that course because 5G licenses are imminent. Okay, there are some 5G trials already took place in our country last year. Okay, so considering that 5G days are not far, I start. I mean, the last few weeks of the course covered only 5G. Was dedicated for 5G. Okay. So, but mostly I cover 4G. The first week I spent on 3G because I mean CDMA concepts are important in many respects. Even if you want to work with 4G, some CDMA concepts one should know. Okay, so first 1.5 week I spent on CDMA concepts, which is basically a 3G technology. Okay. And for 4G, you know, I mean, I cover a very good book. I'm not telling you the name of the book, but probably you can understand what it is, right, guys?
Yes, sir.
Yeah,
Your books
yeah.
are
Okay, okay, thank you.
Yes, sir. Your books. That's really good.
This is how we can see the indication on the display. Uh, there are whole terms for all these acronyms, you know. I mean, but and in this course, okay, also in cellular communication course, many acronyms appear, okay, but you don't have to learn the whole terms, okay, because in the industries people work with acronyms. Okay, I want you guys to become fit for the industries after you take this course. China, well, TDD and FDD, what they are. Okay, I'll explain that later in this presentation and come back here. Now, I say that there are specifications released from ITU. Actually, I mean 3GPP body under ITU. So they use uh, some release numbers. Okay. Under one release number, there can be many specification books released. Today, you can access these books for free. You can download if you just type in on Google 3GPP numbering scheme or something. It will take you to the page. I think I have, yeah. You can say, you can get to this, after Google, you can get to this page. This is the, I mean, there'll be a whole table first for different series. And one of the series is 36. That series is dedicated for LTE. LTE has different things in other series also, but 36 series is dedicated for LTE stuff. So when you go in there, you'll find a number of specification books. each with a number 36.101, 104. And so these are different books you can download. And these are the titles of the books. And there are many books. I'm showing just a few here. And, I mean, the title actually tells you what it is containing. So under one release, there are many, say, sometimes even a dozen of specifications. Maybe a lot of times quarterly they have release. Every 3 months they release a specification version. Okay, but sometimes even more frequently, sometimes even 10 or 12 versions they release. Okay, but there is a whole number. Okay, and in this number, the first technology, when there is a, when you introduce an or you bring about an overall change, and then you use a new term there, like say HSDPA had a, I mean, all this EMTS or everything has newer versions with some advancement always. I mean, over the, I mean, the 3G is also advancing. All the technologies have continuous development, continuous advancement. But when you come up with a great change, and you think that this can be called something new, okay, then that is introduced with a new release number. Its first release comes in a new release number. Okay, so that is how when HSDPA was first added, okay, a new release number was used, and it was release 5. This is more related to the year numbers. Like first, the 3GPP body started their journey around 1999. First, it started releasing around 1999. But by the time they were started HSDPA, it was close to 2005. Okay, then 2006, 7. Okay, they cannot align precisely, but somewhat close to the year. Now, but say when LT Advanced was first introduced, it was release 10. But remember that LT, which was first introduced in release 8, was also had an upgraded release in release 9. Okay. LT Advanced Pro was first introduced in release 13, which is called 4.5G. But LT Advanced, okay, they had their continuous upgradation in release 11 and release 12. Okay, a lot of newer things, new features were added to that. Okay, in these new releases. And 5G was first introduced in release 15. Okay, and currently release 16 is being released. So if you go to the, you'll find all these different releases if you go to that website. Okay. Now 3GPP2 site. These guys used to boast, okay, 3GPP2, because they were under the impression, I mean, the people who worked on 3GPP2, they were under the impression that they would win eventually. There was a hard competition. When I was in USA, I found a hard competition between 3GPP and 3GPP2. But 3GPP, I mean, the overall impression was 3GPP2 side would win for. I mean, there were 6 major operators in in USA when I first got there. But during my stay, there are 2 mergers leading to 4 operators. Okay, so Verizon, Nextel, T-Mobile, and AT&T. So then there are 4 major operators. 2 of them had 3GPP and 2 of them had 3GPP2. Okay, I mean Sprint Nextel merger and Verizon. So Sprint Nextel were on 3GPP and Verizon were on 3GPP2. Now Verizon was the largest operator and they had 3GPP2. So that was also a reason for that impression. Okay. So they started developing, and I won't go. I mean, I won't explain it but you see that their first 2G already start with CDMA. That is one of the reasons for them to have the confidence that they would win. Okay, so they really um, had a smarter position before. But the problem is that their development was not as organized as 3GPP2 had. Because things are so complex, so many things. So they keep piling up. So if you don't have a very good way to organize everything, layering, and organizing everything in each layer. So everything, if you don't have an, then the whole things, I mean, the whole thing, I also actually had to learn 3GPP2 for some reasons, to some extent, okay. That's why I know that 3GPP is much more organized. And so to me, I mean, in my observation, in my judgment, the reason for 3GPP to win is that it is more organized. The development became easier. Anyway, the first high data rate support started with EVDO. They called it EVDO, which could support only data like HSDPA. Its counterparts are HSDPA, HSUPA. And probably, I mean, you may remember that there are some data cards called Zoom. They had some packages. CityCell had some packages called Zoom. These are EVDO technologies. You could support some data cards. So this is and you see that there are some names also. I mean, you see also the names are little. See, the generation numbers are not. I mean, sort of vague. I mean, I don't know why these guys are not that organized. And also, you see the numbers as they developed in the course of time. They have newer stages. Okay, but the first stages they called 0, and later A, then B, then C. Okay, so sometimes number, sometimes later. Also with here video, the first one was Rev 0. Okay, when I was in USA, Rev A, as in the days of Rev 0 and Rev A. Rev A was the first one to have high speed in uplink. Rev 0 could support high speed only in downlink, similar to HSDPA. And Rev A could support high speed in both directions. Okay, I mean, like HSUPA capabilities added here. So, but nobody had the idea that Rev B would be the last one for them. When they were working with Rev C, UMB, the UMB term, we could also hear that. I mean, like, anyway, so UMB was thought to be equivalent to LT, but anyway, I mean, at some stage, Qualcomm declared that, I mean, it was a realization that 3GPP would take over the whole market eventually. And so Qualcomm declared stopping further development of UMB, which is Rev C. And the day Qualcomm declared, the whole world also realized that Okay, I mean 3GPP2 is stopping. Okay. Now only this UMB was using WebDMA. So 3GPP2 side, what they did, also adopted LTE instead. Okay, so Verizon or these guys also after these technologies, they could switch to LTE. I mean, these technologies were still there, but they just added LTE from here, from this stage of evolution. Okay. These are the whole terms for the acronyms. Now, there's something FDD and TDD. These things you may already be familiar with.
Yes, sir, from the last semester.
Oh, you know, okay. So it can be half duplex, like the old cops used to do. You don't know that. Okay, people say over. That is like half duplex. In the full duplex, you have this FDD and TDD options. Okay. Now, these technologies usually have both the, I mean, in the specifications, you have two flavors, FDD and TDD. Okay. But FDD side is more popular. Well, the early ones, say 2G, did not have any TDD option. And actually that was, yeah, I mean, by FDD and TDD, I know, I mean, probably you understand that I mean here, the downlink and uplink communication. When I say FDD, the downlink is on one frequency chunk, uplink on one frequency chunk. I mean, base station transmits on one frequency chunk, and you transmit from your phone on another frequency channel. That's for FDD. So it is called also paired. And in the case of TDD, you don't have pair, a single spectrum you use, but with time multiplexing for base station transmits, and then you transmit again base station, again you, so one after another. So in so the technologies, I mean, say 2G had only FDD option, okay, in the specifications. But in the case of 3G, there are both FDD and TDD options in the specifications. But the whole world except China adopted FDD. Only China used TDD. And this TDD version was also called TD-SCDMA. Okay, look at the last line of this slide. CMD's TDD, only China used. So FDD is more popular because it is less complex. Now, so is true for LTE or 5G. You have both FDD and TDD options in the specifications. But what happened in the real market for LTE? China again stick with TDD, but about the rest part of the world, say I would say 75 to 80% of the world adopted FDD, and TDD had a very small share. Okay, I mean like 80-20%. But it is not 100-0. Like I mean, in the other case for 3G, except China, there is no TDD. But for LTE, there is TDD in some places. And for 5G also, FDD is getting more popular than TDD. Okay. Although if you ask me which one is which one can be more advantageous, I would say TDD. But it is more complex, and I mean that complexity may not worth. Okay. So I think we're almost at the end of this presentation. So here, and this is the summary. Okay, I have already told you that LTE is developed with both FD and TDD, but FDD has larger share. However, WiMAX is deployed only with TDD. WiMAX also had actually in the specification both FDD and TDD, but in terms of deployment, real deployment in the world, only TDD version has been used for WiMAX. Okay. So this is what I have just explained. Now Wi-Fi. Wi-Fi also has evolution and now up to Wi-Fi 6. Okay. So it's called, I mean, the different versions are I mean, 802.11a was the first one in the introduction, but it didn't become popular. Okay. So almost at the same time, B was also introduced. Anyway, so B, G, N, these are the most popular ones. And you can see that the data support here is much wider. I mean, is increasing in the course of time. And Wi-Fi 5 and Wi-Fi 6. Okay, so the new phones support Wi-Fi 6, but I mean the new costly smartphones support Wi-Fi 6. Okay, but you know the router also has to use Wi-Fi 6. Okay, however, it's actually not what capability of your Wi-Fi has. Okay, you may be on a Wi-Fi net 5 supported network, both your router and your receiver, okay, has to support, I mean, your smartphone or your laptop has to support this Wi-Fi version. So if they are both supporting Wi-Fi 5, they are using Wi-Fi 5, your data rate, you know, in our country would be very low, because you see that the at the back end, the data rate, I mean, your router is connected to I mean, this some broadband service provider. So there is a limitation from their end, how much data your router is receiving. So that's the bottleneck. Okay, so this type of Wi-Fi 5 we don't need in our country, right? We don't actually need Wi-Fi 5 in our country. Even Wi-Fi 4, I would say, is not a requirement. Okay. Normally, we are restricted to Wi-Fi 3 capabilities. Okay. However, sometimes it is a little higher. So, okay, the maximum distance also, that also depends on the antenna capabilities. Okay, all these things are improving day by day. Anyway, questions we just have. If okay, I still have. Oh well, I have 10 minutes.
Sir, in the last slide, sir.
Okay, I'm going back to the slide. Let me check if it is the last one.
Sir, what is sir in the last slide, in the sir, last portion, sir, what language this is?
Oh, you can't read it? It's very simple. You can't?
No, sir. What's this?
Oh, you know what? Actually, as I said, it is very simple, but I can't read too. I mean, it is simple with people who have that language native. Okay, it's not my native language, so I can read. I copied it from some source, and I actually now even don't remember what that source is. So it just comes from there. I don't know. I'm sorry about it.
And sir, for the two columns, sir, the maximum distance between devices in the building.
Yeah.
slash on the street meters. So actually, what does this significance? Like, what's the significance
Okay.
of both of
Okay.
them?
That's a good question. Say you okay. I mean, if I look at
Yes, sir.
I mean this
This
column, this column, if you look at, then it will be clearer for me. It will be easier for me to explain. In fact, if you are in a open area, then the propagation is much easier.
Yes, sir.
Okay, in the building, it can propagate, but there are penetration losses. Okay, the penetration losses are, I mean, actually that limit the total coverage a lot. And most of you definitely have the experience that when you are deep inside a building, you don't receive the cellular signals well. So you see that when you are inside the building, the actual coverage area can be, I mean, you're at the receiving end, the signal has to have enough power. Okay. So that is that distance is much smaller. So you see that the distance, but if you are outdoors, okay, where it is mostly open, there can be little obstacles, say in a coffee shop in the open area. Okay, so in this type of area, it is only when it is mostly open, then the signal propagation is much easier. Okay, so the coverage area would be much wider, and it is actually similar, but let me see.
So the right values are quite larger than the left
Yeah,
ones.
yeah,
That's why
yeah,
I was asking.
yeah. Oh, okay, okay. So let me see what that is. I haven't didn't notice before. Okay, I mean, what I was explaining, the reason for the difference between the two sides of the slash, but to me it is also not clear what the, I mean, it is definitely the, I mean, this I mean, it is in terms of feet. Okay, this one, okay, just give me a second. This would be the,
So this column is in terms of the
minimum
inches.
distance. Yeah, yeah. This would be, I believe, would be the minimum distance.
Sir, I was asking because, sir, as
Yeah.
far as I remember, my router or our router, most of our routers are of the 802.11 AC standard. Yes, sir. No, not this one. Yes, sir. This is standard. But, sir, like I can say for my house, like when I turn on my router, it covers like whole of my like all of my rooms.
Yeah, yeah,
Or
yeah.
apartment. So,
No,
sir,
yeah.
35 inches, 35
No,
inches is quite a small place.
no. As I was saying, that it is, I believe it is the minimum distance. Okay, so it's a typo here.
And sir, is it
Is
is it for inches or it's for feet?
No, it's for inches, but it's not maximum distance. It's the minimum
Okay,
distance.
sir. Okay.
It's the minimum distance. Okay. There is also, I mean, the antenna has a, in the close vicinity, the antenna has a different type of radiation. Okay, so the minimum distance for the location of your receiver has some limit also. It's not only the maximum, because the antenna, it is called near field region. Around the antenna, you have a near field region, and the receiver is not expected to be there. Okay, but that doesn't mean that it would not work at all. Even if you put it something in the near field region, you would find that it is working. But normally you are not expected to put anything in the near field region. Okay, and when people specify the near field region, they use some margin. So the practical minimum distance is even shorter. Okay, but I mean in the I mean they are specifying the minimum distance like this. Okay.
Sir,
So I
we
mean,
can sir, we can consider like the minimum radius is 35 35 inches, and the area that's the circle of 35 inches covered, that's the minimum distance, isn't it? Like how you are considering the region, like sir, this 35 inches, so maximum distance, how you are calculating the maximum distance. So like,
the,
are you considering it as like the radius of a circle, or it's like linear distance or something?
it's a circle. It's a circle. I mean, it radiates uh, almost equally in all different directions horizontally.
Yes, sir.
Okay, so it's a circular distance from the router. Okay,
Yes, sir.
what else? But these days, I mean, now I mean, people it uses MIMO. I mean, you have multiple antennas. Okay, so when the routers had just one antenna, then it was purely circular. When you have a router with one antenna, it's purely circular. But nowadays, the routers use MIMO with 2 or 4 antennas. So in that case, it is not purely circular, but it is close to circular region.
Sir, like I saw many people have a concept like the more antennas the router has, the router is that better. Is it right?
Yeah, it is right. Yeah, you have better MIMO capabilities.
Yes, sir.
Okay, I mean, we'll touch upon MIMO later in the course. Just I mean, you can support a higher data rate, or the signal quality can improve when you use MIMO at the expense of a higher number of antennas. Okay. But anyway, do you have any other question? We have just
Another
1 minute.
question, another,
Yeah,
sir. Yes, sir.
yeah,
Sir,
yeah.
another weird question, sir. Like, if we make greater angle in between the two antennas, does it like cover more rooms, or
If
like
you,
does it, sir?
yeah,
Like
sir.
we suppose, sir, I have two antennas or
Mm,
four antennas or something. So like,
mm-hmm.
if I create more angle in between the two antennas, sir, because in the routers we can like move our antennas. So like, if I create a
No,
bigger
if
angle
you
for
were
our, yes,
no,
sir.
if you are on the same floor,
Yes,
you
sir.
should not move.
Okay,
Okay, you move it. You can tilt.
yes, sir.
The tilt option is there if just to allow you some better coverage in other floors.
Oh,
Okay, if you're on the same floor, then you want your coverage restricted to I mean horizontal area. Okay, so you shouldn't tilt then.
okay, sir.
Okay, so if your coverage in other floor would improve if you tilt. All right.
Yes, sir. Understood.
Okay.
And sir, how you're willing to take the attendance today?
Oh, I forgot it. Uh, so I just have to use I mean presents for everybody. So all of your
So, sir,
present.
one thing, sir, I can suggest you like from the class you can download the attendance sheet, and the people who are not in the like attendance sheet, you can only call their names to ensure that they are present. It can like reduce your hassle. Like you don't have to call all the 60 people. Like if Zoom records around 40 to 50 people at least. So you're
Okay, but it's not in the order. Okay, it's difficult to find out from there who are missing. the
Yes, sir.
list.
All present. That's better.
Mhm.
All
Okay,
present. That's
all present is the best option.
yes,
Okay,
sir.
okay,
Today I can see, sir, it's 60 students, and sir, like I think there are 60 students in our course, so
okay,
maybe all are present.
okay, okay. So I don't know, but some of you may use multiple devices, right?
Mm,
No, no, I'm just kidding.
sir, I
Okay,
myself sometimes use multiple devices, but I
yeah,
think today there is not the case.
yeah. Okay, it's I mean, time is up, so we need to wrap up. So, uh, inshallah, I'll see you again. Well, actually, we will meet again this afternoon at 2:30 for our lab
Sure.
class. Okay, so see you then. So all of you are expected there.
Inshallah, sir.
Uh,
We'll see them.
People from all sections should be present there. Okay, okay. Thank you, guys. Thank you for your time.
Thank you, sir.
Assalamu alaikum. Wa alaikum
Walaikum
assalam.
salam.